In this section, we'll be looking at the structure tree. What sets SpaceClaim apart as a direct modeler versus a feature-based modeler is the difference in the structure tree and what it's meant to do. In SpaceClaim, our structure tree is located on the left side of the screen, and it has a few other panels behind it. We'll be focusing on the structure tree. In this case, you'll notice what's in the structure tree are three different solids. The structure tree in a direct modeling system such as SpaceClaim organizes what's on your screen. It's for organizing objects, not for recording every step of a change or modification you've made. So a few of the main things you'll see in our structure tree, which we'll look at today, will be solids, surfaces. These are objects. These are geometry that's on screen. Also, you'll see components and subassemblies. These will be containers which house geometry, and a subassembly will house components. In addition to this, there's two different kinds of components. Components that are internal to this design, and components which are external. External components means we'll be bringing them in from a different file found on your computer. Now that's a lot to take in, so we're going to look at this slowly over the course of this section. The first thing we should look at is why we use components. And there's two main reasons for this. One is to organize your design, and the second is to separate parts. Again, you'll notice that we have three solids in this design. What components allow you to do is to tell you what geometry should be located in which container. So for example, if I pull on this gray face on the outside, you notice as I pull that, it gets bigger and smaller, and when I let go, it merges those two components together. What SpaceClaim is not sure of is, if we're designing a single part, these should probably be merged together into one single solid. You'll notice by pulling two faces, we now have one single solid on the design. I'm going to go to the Quick Access toolbar and undo twice. You'll notice that I have the option, when I'm pulling, to use my toolbar to say no merge, or go to the option to the left and say no merge. This overrides SpaceClaim's default behavior to merge these two parts into one when I'm pulling. I'm going to undo one more time. Now you don't want to click no merge every single time, which is why we put these solids into different components, to indicate where one part starts and another part finishes. To do this, the easiest way is to right-click on one of the solids and to move it to a new component. Once I do that, it gives me the option to rename it. I'm going to rename that part Core. Notice the green solid is in a component, and by selecting on that component, it highlights that solid in an orange box. Now you'll notice that as I'm doing this, I can do one at a time, or I can control select on two solids. If I control select on two solids, I have two options for moving these parts. I can move them both into a new component. Notice that those two solids go inside of one single component or one single container. Now, if I click in white space and undo, let's look at the other option. Is to move them each to a new component. By doing this, each of those solids are in their own component, and I can go and I can rename them now. We're going to rename that purple part Shaft. You can do this by right-clicking on the solid, going to Rename, and call that Shaft. And the other component we're going to call Ring. Now the Microsoft shortcut for getting into the renaming mode is to select, wait a second, and select a second time. Both options will allow you to rename these components. Now we have all of our parts into different components. You'll notice if I'm in pull, and I pull on this green face, none of the parts merge together. You can even have overlapping parts and have them not merge together. This would be common if you were doing an O-ring or a press-fit pin. Now let's say we want to make a subassembly as we saw earlier. This can be done by selecting two components. We'll select our core and our ring, and we'll move them to a new component again. Notice by right-clicking and moving them to a new component, it will create a subassembly. This subassembly we'll name Core ASM. Now we have, in our structure tree, we have our top-level assembly, which you'll notice looks like that external component which I labeled earlier. We'll get to that in a second. Below that we have our shaft, which is a component, and below that is an internal subassembly, core assembly, which contains two components inside of it. Now, a typical way to work, which is pretty standard, is to have one solid or surface or geometric body in each component. This isn't mandatory, it's just a good way to organize data and use it. A good best practice. Now, let's say we want to make a new component from scratch. Let's say we want to add an actuator pin. By simply right-clicking on the top-level assembly, you can make an empty new component. Two things you'll notice when I do this. One, the entire assembly turned gray. I'm going to type in actuator pin. The other thing you'll notice is in our structure tree, one of these components, the actuator pin, is bold. This is indicating an active component. What this means is all new geometry is created inside of the active component. It's a good idea if you're in an assembly to activate a component when you're working on it. Let's show you why. I'm going to zoom in and I'm going to make a sketch of a circle on this face. The exact size won't be important right now. I'll make this about 5 or 6 millimeters. When I go to pull, I want you to notice what happened. First of all, the curves that I made are inside of the actuator pin container. When I go to pull, a surface is inside of the actuator pin container, and when I pull this into a solid, one way or the other, a solid is made inside of that component. To better understand this, let's look at the difference. Here I created a simple actuator pin on the model when I had the actuator pin component active. I'll right-click on 1A rotor and activate the top-level assembly. Let's say I don't want to create a new component, but on the front of this model, I want to actually create a little pin or a little protrusion sticking out of it. Let's say I sketch that same circle I did before. I'll click Circle, click on the front of the model, and I'll sketch a circle which is also 6 millimeters. You'll notice the curves are placed in the active component, which in this case is 1A rotor. When I go to pull, a surface is made inside of the active component, 1A rotor. If I pull this out to make a solid, it makes a solid in the active component, which is 1A rotor. I'm not actually editing this shaft component or shaft solid. And you'll also notice if I undo once, if you sketch a circle on the top level assembly and it makes a surface, this can be used to cut through the entire model. This is a great way for cutting through multiple components at the same time. Now in this case, let's look at what we should have done to make a protrusion on the front of this model. I'll start by right-clicking and deleting that surface. What I should do if I want to edit the shaft, I should right-click and activate that component. Notice the other components get grayed out, and in fact if I go to pull, I can't pull on those components. I can only pull and directly edit the components which are active. Now you'll notice when I sketch that circle, the circle is placed on the front of the model, and that circle sketch is actually created in the shaft component. When I go to pull, it's automatically imprinted as you saw in the pull tool. And when I pull this to make a protrusion or a cutout, I'm editing the actual shaft component in geometry. So remember, when you're working with components, if you make a new component and you want to make a new design, it's a good idea to have it active so the new geometry goes into that component. And if you want to directly edit a single part in an assembly, it's a good idea to activate that component as well. The next thing I want to look at is bringing new components into a design and how we can look at internal and external components. To insert a component into a design, we're going to go to the Insert tab. Here you can insert different files, you can insert standard holes, and you can insert from different catalogs online. I'm going to click on File, and I'm going to show you a few components. This is where we'll start to look at internal versus external components. And in fact, if we look at the structure tree on the left side of the screen, the easiest way to tell if something's internal versus external is there's this little paper icon behind it. Right now there's one icon with paper, which means when we save this design, it'll save as one single file. Now, to know whether a component's going to be internal versus going to be external, there's a simple rule. Geometry you create from scratch in SpaceClaim in a single session will be internal by default. Parts that are inserted, like a balancing pin, will be external by default. Every time we go to use this component that's there, I'll move this up so we can see it better. Every time we use this and work on this, it's going to actually go through and pull on that file, which means if I open that balancing pin up separately and make an edit to it, it's actually going to change in all assemblies which use that file. So if you want to use a single part in multiple assemblies, it's a good idea to have external parts. If that's not something you're looking for and not something you need, I would suggest internalizing a part. By right-clicking on a part and going to Source, you can switch this to an internal copy. And if you select on the top level assembly, you can internalize everything if you'd like. Notice when I internalize it, the icon changes, the paper's removed, and that geometry is inside of the design. I like to think of it as the top level part having strings tied to all of the other parts that are external. Once you internalize it, it sucks that part into the top level assembly and cuts that string and removes the tie. Now, instead of inserting things into your design, if you have a newer component which is sent to you, you can also replace one component with another. For instance, if I right-click on Shaft and I go to Source, we can replace a component. Replacing a component in SpaceClaim brings the new part in and aligns the two origins of each part. If a part was made, it's the same part just modified, there's a very good chance they will have the exact same origin. If not, you might have to use SpaceClaim assembly tools to bring them into the correct place. Now the last thing I want to talk about while we're here is instances in components. It's pretty standard to have an assembly use multiple instances in a design. This means that all instances should be exactly the same. Think of buying a grill and having all these different nuts and bolts and parts. If it says you have 10 screws which are an inch long, they should all be exactly the same. That's the kind of thing we're looking at here. If it says we have 2 identical parts in our structure tree, the geometry inside of them should be exactly the same. Let's take a quick look at it here. And I'm going to show you the difference between moving and copying a solid versus a component. Expand the assembly so we see our core and the solid inside of core. Notice if I select on the solid, you can see the solid highlighted on the right. If I select on the component, you can see the box of the container which houses those objects. If I click on the solid, a quick way to make a copy is to hold the Control key as I drag it in a direction. Let's look at the red direction for now. You'll notice what I copied was the actual solid inside of it. Any change I make to the solid has no ties to the original one. You'll notice the solid on the right isn't changing at all. I'm going to undo once. This is the opposite of clicking on the core on the core component. If I hold the control key down, click the direction to move it and make a copy, you'll notice I have core and I have another core. If I did a bill of materials, it would say I have two core components. You'll notice any change I make to one of them will be reflected in the other. This includes pulling faces, moving objects, filling holes, or merging one thing into the part. You'll also notice this core can be placed in a new location. It can be translated and it can be rotated. However, when positioning things inside your assembly, it's really important that we're moving the component itself, not the solid. You'll notice if I rotate the solid inside of that component, the same way moving one face moves one face on the other side, it stands to reason that moving all of the faces in one component would move all the faces on the other. Now, if you don't want to have this tie or this relationship, you can break this by right-clicking, going to Source, and making that independent. Notice it will change the name to a 2, and now it will be a totally separate part. So there'll be one core and one core 2 in your assembly and your bill of materials. So I hope you've seen different ways we can look at components, we can organize data, and we can have them in our structure tree. The important thing to remember is the structure tree is used to contain objects and to organize your assembly. And a great best practice is to have one piece of geometry, a solid or a surface, for each component or container. Thank you for watching.